Hello there. I'm doing these notes very quickly, I might add, with the full understanding that you get how prisms work. For two reasons. One, I don't have the advantage of time, and two, these are fully based on that. So without re-explaining it twice, I do recommend that you go back to previous lectures to figure out how those prisms work if you still don't get it. Because I do want to jump through this as quickly as possible. This one's chock full of examples and not so much understanding, just more practice and more perception. Now, as you also notice, because I just circled it, this is chapter 11 now. The book kind of jumps around strangely. They go from chapter 9. 10 is some strange thing on circles. 9 also had constructions. We're skipping it. We're going to 11 because it makes the most sense. So this is on pyramids. And pyramids have their own definition. Pyramids are, well, they're not prisms, but they're 3D shapes. They have a base. Okay, just like prisms have a base, but prisms have two bases. Pyramids only have one base. And then their edges, which is what these are called, their edges meet at a central point. I'll call it point, or I'll call it tip. Okay. There are other things you'll see that are labeled. We're going to call this the height, and this we're going to call something else. You'll see that's an L, by the way. It's a cursive L. And here, for now, we'll call S for side. You know what? I'm not going to call it S because that might confuse you with something else. Let's just go ahead and go through definitions right now, and we'll see if we can make sense of it. Do some vocabulary. So there's a thing called the height. So the height of a prism, not prism, we're just talking about prisms. Height of a pyramid shouldn't not make sense, but it's the vertical distance between the point or tip and the base. So just like a triangle, right? When a triangle has, in fact, I should have said perpendicular distance, but when I say vertical, I hope that makes sense. It's the one that needs to go down perpendicularly to meet at the base. And as you can tell, this is in the very middle. It doesn't go down this way. That's a different kind of height. The height of the pyramid itself is the one from the very bottom to the very top, however it is you need to draw it. Just like a triangle, there could be a triangle that looks like this. Obviously, this is the height. Likewise, there's a triangle that could look like this. This is the height. There could be a triangle that looks like that. This is the height. And there could be a triangle that looks like that. And this is the height. So the height is the vertical distance that we draw. Okay? And in 3D, it's the same way. And that's the same with the prism. With the prism, it goes from bottom to top. Same way. This L right here, this is called the slant height. And I guess you'll have to use L with the word slant and make sure that you get that's where it fits. The reason why we're not using S is because S is for sides. Lengths of sides, I suppose. The slant height of a pyramid is the height of any of its lateral faces, so the triangles. So let's sit and talk about pyramids for 1 second, and then I hope I can save myself time for the rest of this. So a prism, okay? Imagine that I have a prism with this same base. Now I draw everything upward with that height h. This isn't opaque, it's see-through, but hopefully you can see this prism here. So here's the height h. Here's that other side length. Let's call it b, for instance. That's b and all that stuff. So here's a prism, here's a pyramid, okay? They're right next to each other. Now, when we draw the net of a prism, the lateral faces, these guys right here, they are rectangles. Because the bases are both the same, and yeah, they're the same, they're parallel to each other, so all these have the same height. These are all rectangles. Here, if you imagined unfolding this, if I unfolded everything from the top and I bring this downward, and I bring this downward, etc., I bring all of these corners down, you no longer have lateral faces that are rectangles. If you look down here, a pyramid unfolds to the base and its triangles. Now, we haven't practiced drawing nets that way with prisms. I could have if I wanted to. I could have taken this and unfolded everything downward that way, as long as I get the base attached to one of those. We haven't practiced it that way, and we should, and we will. But a net of a pyramid has lateral faces as triangles, not as rectangles anymore. And there's only one base. So we'll keep that in mind when we do surface area right now here. The surface area of anything is the area of all of its faces. In this pyramid, if I take this pyramid and unfold it, and this is a square pyramid, by the way, because we refer to it, we designate its name based on what the base is. So this base is a square. Now, the lateral faces are triangles, but you add up the areas of all the faces. Now, as we did it last time, for a pyramid, the surface area was the lateral area, the area of the lateral faces, plus this base, plus this base. So we had surface area of prism was lateral area plus 2 times b, because there were 2 bases. Okay. Surface area of a pyramid is going to be the lateral area plus 1b, because there's only one base. You can see here, here's the lateral area, the 4 triangles, 1, 2, 3, 4, and here is the one base. So I'm going to add those all up. So that's the difference between prism and pyramid. Is pyramid only has one base and it has triangles, lateral faces. Okay, so again, taking the surface area here, I want you to check something out. So we did say LA plus 2B. I'm first going to write that on top. Or, I'm sorry, LA plus B. I'm going to write that one on top. The lateral area, remember, we said they're triangles. Now I'm going to ask you, well, what's the area of a triangle? Okay, the area of a triangle is 1/2 base times height. Okay. Now, that's the area of one triangle. How about taking the area of all the triangles? Now in this case you'll say multiply by 4. I agree with you, but not every pyramid will have 4 triangles. So you have to just multiply by the number of triangles. Let's call that n for now. Right, we did this before. This looks kind of familiar. We're going to translate it a different way though, sort of. B, area of base. Okay? In this case, in this particular case, the area of your base is base times height, or side squared, right? I'll still stick with B for now. B is area of base. Now, let's check this out. Remember what your base is in base times height. This is your B. This is your H, right? Base times height, base times height, base times height, base times height, etc. All of these heights are the same. If all of these heights are the same, I could factor out an H, and I'm left with, well, I could factor out the 1/2 as well. I'm left with B times N. Remember what N was? N was the number of triangles. How many triangles here are there? Well, there are 4. Now B, check this out. B in this case is the same all the way around. If I multiply B by 4, I get 4B. 4B is the same as the perimeter of my base. Okay, we talked about this before with prisms. That's why I'm not going to spend that much time doing it. So I'm going to say it right now. This is the B times N. Here's the perimeter of my base. Now H isn't really H. I want you to keep that in mind. When we unfolded this, we looked at this line right here. We didn't call that H. What did we call it? L. This is the slant height. So before I talked about 2D triangles and I said, well, okay, H here will be height, but really this is an L. This is really our slant height. So I'm going to convert this all and redo this one more time. You know, feel free to erase in your own notes. Your surface area will be 1/2. Remember we did B times N. B times N is the perimeter. Perimeter times slant height. Okay? This will give you your lateral area plus your area of your base. So the surface area, you might want to box this, maybe even rewrite it. Surface area of your pyramid is lateral area plus area of base. Your lateral area is found by finding the perimeter of the base, multiplying it by your slant height. Okay, so P is perimeter. L equals, look, it shows right here. L is the height. L is slant height. B is area of base. Okay, moving on. I'm going to do an example, and I'm going to write some letters in here. Fold your square base pyramid, so we're not going to actually fold one, but we'll visually do it. Find the surface area. Let's get this out of the way. We're not using a ruler. I'm just going to give you values here. I can't seem to draw straight, though. Okay. Let's change these values. Let's change the S to a 4. So this length is 4. Let's change this slant height to a 3. Okay? So you have a pyramid. So this pyramid has a length of 4 and a slant height of 3. So maybe they show you this and then you have to draw the net, right? So your surface area is your lateral area plus the area of your base. Your lateral area is 1/2 perimeter of your base. So what's the perimeter of this base? If all these are 4, 4 plus 4 plus 4 plus 4, that's 16. Times your slant height, 3, like so, plus the area of your base. What's the area of this base? 4 times 4, 4 squared, that's 16. Okay? And the rest is just math. Half of 16 is 8, 8 times 3 is 24, 24 plus 16 is 40. So let's put 40 square units for that. And again, I know these notes will be more examples and they'll be a lot quicker and such. And actually, this is my only surface area example. I'm going to give you one in your homework, your very first one, if you have any other questions on it, because it's just a little bit different. You do a couple of different things as you go along. Okay, and then volume of a pyramid. This one, I'm going to save time as far as explanation on how it is or how you can figure it out. I think I'll link a video for you later in your on the thread itself, but for now I'm just going to say trust me on this one. So let me type this one out because I don't want to write it all. The volume of a pyramid with base B and height H. Now remember, base B means area of the base, not one length. It's the area of the entire thing. So it might not be a square. It could be a triangle. It could be anything else. Is exactly 1/3 the volume of a prism with the same base and height. So let me take some time to talk about that. Okay, volume. Again, volume means fill. It means if I could fill this with water, right? If I fill this whole thing with water, how much is that equivalent to other things? Like if I put it in a graduated cylinder or, you know, a beaker. Okay. Imagine for a second if I have a prism with the same height and base. So remember, here's my height. It's the actual vertical distance, h, not slant height. But I have this height. It goes from bottom to top. What if I had a rectangular square prism with that same, let's see, that same height like this, sort of, and then it goes all the way around and around the back, etc. So if I had a prism here, it has the same base. So this base is right here, okay? You can see it. There's this base and there's this base on top. Okay, makes sense. Here's 2b. Here's the height. It's the same as this height over here. Okay? So they have the same base and height. Now the volume of this base is obviously area of base times height. I'm sorry, the volume of the prism. The volume of the pyramid, there's no way to prove it right now. You know, I can't really show you exactly, oh, look, this is how it works, whatever. But the volume of this pyramid is exactly 1/3 of it. So if you can find the volume of the prism as base times height, area of base, by the way. The volume of the pyramid is 1/3 area of base times height. So again, I'll do it one more time. Volume is 1/3 area of base times height. So you find the area of the base, whatever it is. It might not be a square. It might be a triangle or a hexagon or, whatever it is. Multiply by the vertical height, right? That's how you're going to get the volume. So right now, trust it. We'll find ways to practice with it in class because it's really hard to prove. You can use practical ways though. So let's do a square-based prism, square-based pyramid here. And it's not really square-based, it's more rectangular-based because the bottom here is not a square, it's a rectangle. It's a 5x4 rectangle. So the volume, again, it's 1/3 area of base times height. Let's get each thing individually. Your height is 6 feet. It just is. We can see it. Nothing you have to do there. Area of your base is base times height, or, so length times width. 5 times 4, which is 20. So your volume is 1/3 area of base times height. Okay, 1/3 of 6 is 2. 2 times 20 is 40. So again, we get 40. This is cubic feet. Okay. Let's do a triangular based one. So again, here you have a right triangle with legs 6 and 7. Now remember, in a right triangle, if this is your base, then this is your height, because that's perpendicular to it, so it's perfect. And this height right here, look at this. This is the vertical distance from base to point, to the top, to the tip. Okay? So that's 8. So we have height is 8. Area of base, check this out. Area of base is 1/2 base times height, right? 1/2 7 times 6. 1/2 of 6 is 3. 3 times 7 is 21. So we're going to do volume as 1/3 area of base times height. Okay. 1/3 of 21 is 7. 7 times 8 is 56. So your volume is 56 cubic meters. And again, I'm going through these problems kind of quickly here. You can pause and slow down and use the calculator and try and follow along, but again, time is of the essence. I want to get these last few in like 4 minutes. Okay, square-based again. Let's do a few more. Round to 2 decimal places? Okay. I don't think we'll have to. Volume. Again, it's 1/3 base area of base times height. Make sure you don't forget that 1/3. That's the whole principle behind it. I might forget it every so often. Your height is 7. Your base, 6 times 6, 36 square inches. So your volume is 1/3 area of base times height. 1/3 of 36 is 12. 12 times 7 is that 96? I think it's 96 cubic inches. Okay. Square, but come on, why are they saying square based? Rectangular based. This is rectangular based. Area of base is 9 times 8, which is 72. Your height is 5. So your volume is 1/3 area of base times height. 1/3 of 72, that is 24. 24 times 5 is 120. So you get 120 cubic feet. There. And finally, triangular base. Again, remember, this is the height. Okay, 11. So your height is 11. It's vertical. Area of your base. Now this is a triangle. Okay? This, again, just like the other one. If this is a right triangle, here's 8 and 13. You have to do 1/2 base times height. Don't just assume everything's base times height down here. Okay? You have to know what your thing is. In fact, with hexagons and such, it'll be 1/2 apothem times perimeter. It'll be a little more difficult. So this one is 1/2 base times height. Half of 8 is 4. 4 times 13 is 52. So this is 52. So your volume is 1/3 area of base times height. 1/3 of 52. Is that a real value I can do here? That I don't know. Probably not. Let's see. 1/3 of 52. Here, I'm find a calculator. Third times 52 times 11. So I get 190.67 when I round it. 67 cubic meters. Okay, so that's volume and surface area of pyramid. I'm sure there will be a lot of questions as far as what or how to do whatever, but hopefully these example problems get you a good start. I know you're going to have a lot of questions with the surface area stuff because slant height and all that stuff in the unfolding, so we'll get through it as we need to. But hopefully this was a good start.